Hello and welcome to chapter 10 of Python for Beginners. I'm excited about this chapter. We're going to be talking about several of the things that you need to round off what you've already learned. So in this first part, we're going to talk about error handling and how we're going to take care of errors as we find them. And obviously we're going to introduce some errors and see what happens when we do that. And so as you write more complex code, it's inevitable that you're going to introduce errors into your programs, and you want to know what to do if you find those errors. So error handling basically refers to the process of anticipating and managing errors that can occur during the execution of the program. So these errors could be due to things like incorrect user input, missing files, network issues, calculations that result in invalid numbers, things like dividing by zero, etc. Without error handling, a program would just simply crash. And then when it encounters that error, basically everything's done. Not a great experience for the end user. So it's good if you can control how your program is going to respond and you can have it gracefully bow out. So common Python errors, one of the big ones is syntax errors. Now what syntax means, it's if you're typing in something here and you miss off something like that colon there. So if I take that colon away and I run this program, what's going to happen? It's going to run and it's going to pop up a syntax error. Now I can't catch that error because that error occurs at pass time, not at execution time. So if I want to catch a syntax error, I basically have to get it to pass it first, and it sort of defeats the object. But one thing you can see, when I have a syntax error, I got the syntax error pop up, and this big orange line you can see is telling me where that syntax error is. So if I run that one more time, we'll take a look at the output. It says syntax error expected colon. So I say, okay, I go over here, I put my colon in, and my big orange line disappears, and that will work now. So a syntax error is not something that you are going to allow to be in your software. So when you're testing, you run it, you'll see if you have a syntax error right away because it's going to get passed first and it'll pop out as a syntax error. So those ones are pretty straightforward. A type error is if you have something like a string and an integer together. So if I put in here some text, I'll just say text, and I'm going to concatenate that and test it against 18. I'm going to run that. And when it runs, I'm going to get an error. And the error that I get will be error can only concatenate string, not integer to string. So that's the actual error. And if you want to see my error right here, I'm going to show you the output of that. So it's error can only concatenate string to integer. Can only concatenate string, not integer, to string. So that's an important one. So those type errors are something that you might come up against if you are putting values into variables and you don't realize that you haven't changed it to a string. 5 might be a string, but for 5 to be a string or 10 to be a string, you need to enclose the 10 in quotes so that it then becomes a string and not a number. Another common one is dividing things by 0. So if we look here, this x divided by 0. So I'm going to make this one work now. So I'm just going to put that 8 back up there. So of course 8 plus 10 is 18. So it's going to try and execute this code. It's going to say x is greater than 10, which is not really what we want. So I'm going to change that and say we executed this code. We executed, if I could spell, this code. And then I'm going to try dividing 10 by 0 and assigning that to x. So let's see what happens there if I run that. So, okay. And over here, you'll see we executed this code, and then I get an error. Division by 0 error. Doesn't love that. So you can't divide by 0. And that could be one that happens in your software, because you might have something where a calculation ends up being 0. And so you might want to prepare for that one. And then, of course, there's a value error. So if you try to make a string an integer, for instance. So let's try that. So if I say integer and I say string, any string could be any piece of text. So I say integer string. If I run that one, and then what's going to happen is it's going to come back and it's going to say error, invalid literal for integer with base 10 string. So it doesn't like that. It's not going to allow you to turn a string into an integer, of course. And then you can also get a file not found error. And these are just examples of errors and not every single error. But you can get the file not found error, and that would be raised when you try to open a file that doesn't exist. So that's another one that you might want to look out for in your programming, because you might be saying, let's open this file, and then if somebody deleted the file, that could be a problem. Now, you probably noticed when I'm running these, my program is not crashing. And the reason it's not crashing is because I'm using a try, up here, try, and an except block. So when you run a try and accept block, what it's going to do is it's going to say, I'm trying this, and if I fail, I'm going to look at this piece here. Now, with those except blocks, you can make them specific. So I could say this is a zero division error block, and it will go off on a 0 division error. I could say it's a value error, except a value. So this could say value error right here. And if I do that, it will do whatever's down here if it finds a value error. Now, what I've used here in this case is what they call an exception block. So what this exception block does is any error that it finds, it is going to load it into E. And then what I'm going to do is I'm going to print that error, and I'm going to print out whatever E was loaded with. So when you saw those printouts that I had, it's because E was being loaded with those errors. So I like the exception one because it's a catch-all. But you might want to be more specific. So you might want to do something different if it's a 0 division error or if it's a value error. So you can imagine if you had a try and accept block, and you said 0 division error, somebody puts in 11 divided by 0, you can pop up, you can't divide by 0. If they try 11 divided by x, you can say that's not a valid number because you get a value error. So for different errors, you might want to have different messages. You might want to do different things. You might want to say if x is 0, make x 0.0001, just so you can do the math, that kind of thing. So there's lots of things you can do in these except blocks. So if you wanted to, you could have an except for all the different errors. And then you can do things like, if all those errors are not accepted, they're not an exception, not accepted, but accepted. So they are not an exception. They're not something that's going to cause a problem. You can use an else. And the else you would put in here and say, do whatever you want it to do then. In my case, I'm going to run my program. So you can try a bunch of possibilities, and if you don't get any errors, it will do whatever's in the else part. So I'm going to make this, instead of saying int string, I'm going to say int 10.2. So now we should have valid code up here, and so we shouldn't get an error. So it should print run the program. So let's take a look. So here you can see the one at the bottom here. It's actually, let me redo that. I'm going to redo it. I'm going to run it. All I did is close that window so that we could start again. You don't see all the other stuff. So we executed this code. That's the piece up here because 8 plus 10 did equal 18. And then we turned 10.2 into an integer. So that's perfectly valid. All I'm doing is taking off the 0.2 in that case. So the exception, there is no exception, nothing errored. So we are going to run the program. So here's my run the program. And then finally, there's a thing called finally. What finally does, no matter what happens, it's going to run what's in finally. So if there are errors or if there are not errors, anything in finally is going to run after that. So where it says we're doing this no matter what, well, that's the case. If we had an error, we do it. If we don't have an error, we do it. So you can use those finally blocks to help yourself. Now there is a thing where you may say to yourself, well, what if I want it to be my own error? Something that is an error, I want to force it to be an error. So you can raise an error. And when you raise an error, what it does is it causes that error to be true. So even if your calculation hasn't happened yet, you could do something like this. So I'm going to say, if number is less than 0, I'm going to raise value error. Let me just tell it. The number must be positive. So then I'm just going to go up here and tell it that number is equal to -5. And now what's going to happen is I'm going to run my program. And as you can see, because I've got my exception here catching everything, we executed the code, this part. It got to this, if number is less than 0, and it raised an error. And the number must be positive is the error. And it raised it right here. So this said there's an exception, it's a value error, and we're going to print the error. And our error is the number must be positive. So we basically forced it to a value error before we caused a value error. So we tested to see would we get a value error. And if we would indeed get a value error, we can raise that value error to make our program process that as if we had caused a value error. So that's a preemptive way to make sure we're not running into errors. And then finally, you can do custom exceptions. So what if you wanted that to say something else? Well, you can create a class that inherits from the exception class. So exception is a class. So if you create a new class that accepts, or that is called something that is inherited from the exception, so you can make up whatever you want that class to be called. So we'll have a go at that. Let's just do that right now. We'll do it above here. And I'm going to create a class. And I'm going to call it negative number error. And I'm going to tell it that it's inherited from exception. And all I'm going to do in that class is just pass. So it just allows me to set up a class with that name. And then what I'm going to do here, instead of raising a value error, I'm going to raise my negative number error, being careful to make sure I've got the same spelling up there. So I'm going to raise my negative number error. And then if I run that, we can see that my error is the number must be positive. So, and of course I can have that say whatever I like. So I could change that and say negative numbers not allowed. Run that one more time. And there you can see my error is now negative numbers not allowed. So once again, you can create a class for your own error type, and that will allow you to get it more specific to your program. So in this first part of this video, we've basically covered common errors. And we've introduced several types of errors that you might encounter, including syntax, value error, file not found error. And we've learned how to use the try except blocks. Those are super important to use. I would use them in almost everything that you do. And I've showed you also the else and the finally parts of the try except. And then also raising a custom exception. So we covered how to do that class inheritance, and create your own exceptions. So just with what you've learned there on the error handling, that should help you to have much more robust code. So now what you need to do is practice them. So do some try and except blocks, and try building a program, and then try with input causing that program to fail, and handle your errors gracefully. So that's basically the try and except and the error handling. The next part I want to do is some regular expressions. And if you've ever done any Unix or Linux or that kind of stuff, you've probably played with regular expressions before, but they're important to know because they're super powerful and a good thing to have in your arsenal. So the basics of regular expressions. There's a module, and it's called RE, or regular expression. In Python, it's included, so you just have to import it into your Python program. And a regular expression is a sequence of characters that defines a search pattern, and it allows you to match complex patterns in strings, such as validating email addresses or phone numbers, extracting specific parts of text, replacing parts of strings with a pattern. So using the RE module, Python provides the RE module to work with the regular expression. The most common function from the RE modules are RE match, which checks if the regular expression matches the beginning of a string. RE search, search for the first occurrence of the pattern in the string. RE find all returns a list of all occurrences of the pattern in the string. And RE sub, which replaces occurrence of the pattern with a specified replacement. So the basic syntax of a regular expression are a dot, which matches any single character except a new line. So the caret matches the start of a string. The dollar matches the end of a string. The square brackets matches any character inside the brackets. For example, A-E-I-O-U in the brackets would match any vowel. Backslash and a D matches any digit, equivalent to 0 to 9. The backslash W matches any alphanumeric character. So that can be letters and digits. The backslash S matches any white space character, spaces, tabs, and new lines. And then the plus matches one or more of the preceding characters or pattern. A star matches 0 or more of the preceding character or pattern. And a question mark makes the preceding character optional. So a question mark makes the preceding character optional. It matches 0 or 1 occurrence. Basic regex examples. We're going to go over a few with matching a pattern at the start of a string. So we can use re.match to check if a pattern occurs at the beginning of a string. So let's take a look at that. I'm going to get rid of this regular expression.py. So first thing I'm going to do is I'm going to go to the top here and I'm going to import re. So that's my regular expressions. Then I'm going to say my pattern is equal to R hello, and then my text is equal to hello world. Then I'm going to say match equals re.match pattern text. And I'm going to say if match, which means if we found one, that will be true. If we didn't find one, it's going to be false. Print pattern found, and then I'm going to go else. So if we didn't find one, we're going to say print pattern not found. Get in there. There we go. So now if we run that, we should see some output. And as we suspected, our pattern was found because we are searching for hello in world, hello world. So as we can see, if we go back over it, we imported our re, our pattern is hello, our text is hello world, and our match is to match pattern in text. So if match, that means if we found it. So what happens is this gets set to true if this match is true. If this match is false, so if I say, let's see if we can find test in there and I run that, you're going to see pattern not found because test is not in there. So this is not true. So when you do an if and just this value, you're saying, is this true or is this false? And it's only going to be true if we find something in there. So let's do that again. I'm going to run that one more time. And there it is, pattern found. So when we're looking for a pattern, the match is going to look for that regular expression at the beginning of the string, right? So that it's looking for hello at the beginning. And so what do you think will happen if we change this to world? If I run that, we get pattern not found because this does not begin with world. Okay, so let's move on. If we want to search for a pattern anywhere in that string, we're going to use re search. So I'm going to make that world, and instead of using match, I'm going to use search. So re search that pattern. And so if we run that now, you can see the pattern is found. Last time it wasn't because we were using re match. Now we're using re search. It's looking the whole way through here to see, is there a world? And sure enough, it's finding it. Okay, now one thing I want to address, and it's the elephant in the room. Over here on our pattern, when we use R in front of that pattern, it makes that raw string. So it means if there were something in there like a backslash, it would treat it as a backslash and not escape that character. That's important to know, because even though we don't really need it on this one, and you can take it obviously interchangeable, when we start using the other patterns, we're going to need that raw part. So we need to make sure that it treats backslashes literally and doesn't interpret them as escape sequences. So I'm going to use the raw string here when we use different matching patterns. So I just wanted to be clear on that R is not necessary. It's interchangeable right now. But this next one that we do, we're going to do find all occurrences of a pattern in a string. And we're going to use the find all, and we're going to put a pattern in. So this time the pattern is going to be, and again, I'm using that R because I'm going to use a backslash and a D and then a plus. And if you remember with our backslash D, that means any digit, so 0 to 9. So we're going to allow it to do 0 to 9, and then the plus says matches one or more of the preceding characters or pattern. Okay, so now it's going to try and find all the numbers, and my text is going to be, I'm going to change this text up to include some numbers this time. So I'm going to say there are 12 apples, 24 oranges, oranges, and 7 bananas. Bananas. I'm a spelling nightmare today. That's 7 bananas. And then I'm going to use our match, and I'm going to say match equals find all, one word, the pattern, which is this, in my text. And then I am going to say pattern found, and I'm going to print the match. So we'll see what it actually found. And so I'm going to run that. And here, if you look, my pattern was found, and it found a 12, it found a 24, and it found a 7. Put them in a nice list for us. So we can extract digits out of text, do it fairly easily. And then we can replace text using regex as well. So that's sub, we're going to use sub this time. And what we're going to do is we're going to change our program a little bit here. We're going to say our pattern is going to continue to be our digits at any instance of them. And we're going to say our, in this case, we're going to say it's new text. And it's going to equal resub, so substitute. And then our pattern, which is going to be any digit. And we're going to enter a pattern here. So we're going to change any digit to XX in text. So then we're going to say, bring my print back over here. I'm just going to say print updated text equals, and then this one, instead of being match, is going to be new text, because that's what we made it equal to. And then I'm going to run that one, and you can see my updated text. There are XX apples, XX oranges, and XX bananas. So it changed all of the numbers to XX. And then a common use for regular expressions is validating user input, such as email addresses. And here's an example of how we can check a string to see if it's a valid email address. Now, this isn't the be-all and end-all of checking email address, but it will definitely give us an interesting look at RE and how we can do interesting things with it. So what I'm going to do is I'm going to create a little subroutine, a little function. I'm going to call it is valid email. And the cool thing is you can build a lot of these into class, and then you can have that as your validator class, which is what I normally do. Then I just have to include, I just import my validator class into any program. Then I can use those validation routines in any of those programs. So you only have to do them once. You don't do it every time you do a new program. So in this case, my pattern is going to equal, again, it's raw, and it's going to be, if you remember, I'm going to just take that out of there because I don't want to be confused. So it's going to be at the beginning, which is my little caret. That's the Shift 6 on a US keyboard. And then a square bracket. And I'm going to say A to Z. So it can be any character. Capital A to Z. Any uppercase character as well. And then I'm going to say 0 to 9. So any digit. Then I'm going to use an underscore. And I'm going to say dot plus and minus, and then a square bracket. So it's anything inside those brackets there. And then I'm going to say plus an at, because you need to have an at in an email. Then a square bracket, A to Z, A to Z, and 0 to 9, dash, square bracket. Oh, bless me. Plus, and then a black backslash dot, square bracket, A to Z, A to Z, 0 to 9, and then plus $. So we've got to have something after the dot. There has to be something. It doesn't matter what, there just has to be something in this case. And then I'm just going to take these guys out of here. So that's my pattern. Then I'm going to say if rematch, and of course, pattern email, which is what we're passing to it. We're going to return true. You should use the uppercase so that that return comes back true. Else, and don't forget colons on these ones, we're going to go return false. And then in here, I'm just going to make email equal to test@example.com. So that's a good one. I need to make that a string, so I need to have that in double quotes. Of course. And then we're going to say print, and we're going to call our function here is valid email. Say email. So that's going to test that one. And then we're going to say email equals not an email. And then we're going to print is valid underscore email. There again. So I'm just going to review that before I run it with you. Let's take that off. We don't need that line anymore. And so this one is, my function is valid email, and it expects to receive a string that is email. So in that case, this could be called anything you like. It doesn't have to be called email. We just kept it as email because that's what it is. So once it receives that email, the pattern is set at this, and it says if we match the pattern in the email that got passed to us, return true, otherwise return false. Then in this next line, we set email to be a valid email, and then we print out the result of this. So it's going to print out, hopefully it's going to print out true, if that is correct. Then we change email to be not an email, and we send that to our function, and it should print out false. So so for that's not going to work, is it? I got the wrong guy on there. There we go. And it needs a second closer. Like that. All right. So now we're going to run that. And we'll see what we get. So my typing continues to be terrible. And let me just show you the error that I got, because it's important that you guys see these things. So what happened is it went through this one and it read is valid email, and said true. Then it got to this one and I misspelled valid. I put VAILD. So it said, when I looked at the error, it says traceback, line 15. There's something I want to show you here. So in our editor here, if we go options, we can say show line numbers. So you see that's under options, show line numbers. So this is hide line numbers now because I showed them. So when it says here, it says line 15, I know it's this line here that is having a problem. And if we look, it says veiled email instead of valid. So I'm going to change that. I just thought I'd share that with you because sometimes it's good to know how do you solve it if you find a problem. So it actually said to me, name error, name is veiled email is not defined. Did you mean is valid email? So it's quite helpful. Try to help me. So now we're going to run it. And what do we expect to see? Well, we expect to see true and then false. So this one, when it prints this, is valid email, true. When it prints this one, is valid email, false. So you can, if you set your email to the result, you could say if email. And so you'd have a true or a false. So if email, you can say, hey, that's a valid email. You can say, otherwise you can say, no, it's not a valid email. So that is a good way to test it. So we can literally do, instead of just saying that, we can say if is underscore, I'm going to try and spell it right, valid email. And of course, we've got to use email as our test there. And I can say print you entered a valid email. And I'm going to just take that one out of there now, because we don't need to print true there. So now I'm going to run that, and you should see that it will say true. When it comes back from here, this is valid email results in a true. So if valid email, print, you entered a valid email. And then, of course, we could use an else block. Wow. A typing nightmare today. Email not valid. And so what we would do is, instead of printing false over here, I'm just going to switch those two over. And I'll just make that one a comment. Now the email is not an email, so if I run this, email is not valid. So it comes as false. So that goes back to what we were talking about before. So hopefully that has helped with our RE, our regular expressions. And it's an important concept because regular expressions can be used for all kinds of things, and they are a bit scary when you look at them. Like, this is quite difficult to understand right off the bat. But work through it bit by bit and you'll understand. So the explanation of that is that first part through there matches the beginning of the string and allows a combination of letters, numbers, and certain symbols before the at. And then the second part matches the at symbol followed by a domain name character. So you got at and then something here. And then the last bit matches the period followed by a domain name extension like .com or .org. Okay, so we're going to use groups for capturing part of a match. So one of the things you can do, and I'm just going to get rid of all this because I don't need it right now. I'm just keeping my import in there. I'm going to put a new pattern in place. So my pattern is going to be, remember, R for raw, and it's any digit. And then I'm going to put in a string that is apples. So it's not sapples, it's a string, \s, and it's apples. And then I'm going to make my text equal I have 12 apples and 10 oranges. And of course, I need my quotes. I always forget my quotes at the beginning. And so then what we're going to do is we're going to search for our pattern. So our match is going to equal RE search pattern text. And if match, so we found something, remember if that's true. we are going to print found number of apples print out the match group. Which is match group 1 in this case. Else, we're going to say we didn't find it. So if it doesn't find apples, then it's going to just print not found. All right, so let's have a look. We're going to run that. So I found the number of apples was 12. And so in this case, the /d plus part of the pattern captures the number before apples. And match group 1 returns the captured value. So that's another way that you can say, you have some text with some numbers in it. We're looking for the number that comes before apples. We'll catch that one. We can do that. We could say oranges. So we can change this to oranges. And if I run that again, probably should change this to oranges so as not to confuse you. If we run that again, now you can see that we found the number of oranges is 10 because it looked for oranges and found the digits in front of oranges. So finally, what we're going to do is we are going to wrap up with some graphical user interfaces. Now, obviously, when you're doing these programs, it's all well and good to have them pop up into the shell, but you actually want to have something that users can interact with. So the graphical user interface, it'll allow you to add things like buttons, text boxes, labels, and other visual elements instead of using the command line. So Tkinter is something that is included with Python. It's one way to create graphical user interfaces. There are many ways. The PyQt6 is another one, which is actually pretty good, and I've used extensively. But we're going to create something simple in Tkinter. So it's a standard Python library, and it provides a set of tools, creating windows, buttons, labels, text fields, other widgets that you can use to make interactive applications. And because Tkinter comes pre-installed with Python, you don't need to install anything extra to get started. Just import it, and we'll start building. So the first thing we're going to do is we're going to create a basic window. And what I'm going to do is I'm just going to get rid of this. We no longer need that. And I'm going to save this one as GUI.py. GUI graphical user interface. There we go. So I'm going to save it as that. First thing we need to do when we create something with Tkinter is we got to import Tkinter, of course. So we're going to say import Tkinter as TK. That's a very common beginning to something with a Tkinter interface. So the first thing we're going to do is we're going to say, we're going to define on exit. And this is a function. We are going to say root.quit, quote, quit. And that's just to exit the application. So that's the first thing that we're going to define. And then in our application here, we're going to create the main window. So root equals tk dot TK and parentheses. Oh, messed that up. Parentheses. And then we want to give it a title. So we're going to say root title. And we'll just call it my first graphical user interface. And then we're going to tell it how big this thing's going to be. So root geometry. And then we're going to call it 400 by 300. And I should have put that in quotes over here. There we go. And then I'm going to create an exit button on here. So it's going to be exit underscore button. And that's going to equal tk dot button. So that's a standard widget. And my tk button is tied to root. The text on it is going to equal exit. Oh, I should quote that. And my command for this button is going to equal on underscore exit. So it's going to run that routine that we just created. Then we're just going to close the parentheses. So now we simply have a button on there that's going to let us exit. And then I'm going to say exit underscore button. And I'm going to use dot pack. That puts it on to my window. And then I'm going to root dot main loop. So we can actually start our app. So let's go ahead and we'll run that. Oop, I missed a colon off there. Remember, we get that orange thing if we miss something off. Let's try that again. And there it is. Here's my first GUI. I have a button. All the button does is exit. Here's my label. Remember, we gave it the root title is my first GUI. So this window is called root. Its title is my first GUI. The geometry, 400 by 300 is the size of this box. And then my exit button is that TK button. And the text on it is exit. And the command is on exit. So that's going to be this thing is just going to quit. And I'm just going to hit that. And we should just quit. Okay, and so that will quit. Now, if we want to get rid of the window when we quit, we can do root.destroy, and that will actually close the window. So let's take a quick look. The root.quit quits my loop, but it doesn't close my window. So we are going to hit exit there, and that root.destroy will actually close the window. So quit is just going to allow it. It's just going to keep running, or the window's going to stay there, but the loop has stopped running. So now it's not doing anything, but the destroy is going to take it off our screens for us. Okay, so that's a basic Tkinter application. And what we can do is we can add a button to that. And so we're going to do another button, and we're going to give that button something to do. So we will do this. We will say def on button click. And then we're going to just say print. We're just going to print button clicked when we click it. So now to add a button, we simply give our button a name. So we're just going to call this one button. And we call it a TK button, because that's the widget. And we tell it it's attached to root. This text is going to be click me. And this command will be on underscore button underscore click. Gotta make sure you get your underscores and your minuses correct, otherwise it's not going to work. And then we need to pack our button. So we're going to pack our button. We'll do it right after our exit button. So we're just going to say button.pack. And then we will run that. And here we can see we have a click me button. And when I click it, if we bring in our little shell here, you can see when we click it, I'm going to move that over here, over here. So if I click it, I get button clicked. It prints button clicked, button clicked, and then exit will take us away again. So you can see it's pretty simple to add a button. And of course you can have on this button click, this could be anything you wanted it to be inside that function, because you know how to work with functions. So another thing you can do is you can add a label. So a label is the same sort of syntax. So if I want to add a label, I can say add it here. I'm going to say label equals, and the widget is called a TK label. And the same kind of thing, it's attached to root, and the text is going to equal hello Tkinter. And that's my label. And then of course I've got to pack my label. So I want to pack it on. I'm going to pack it right under there. I'm going to say label dot pack. And now if we run that, you should see that there's a label there. And there it is, hello Tkinter. My label's sitting right above my button. My button still says button clicked, and my exit button still exits. So again, you can see they're very simple to add widgets here, and there's lots of different widgets. We can add a text field, very similar to adding our label. So what we're going to do is we're going to add a text field, and we'll just add it here. We'll call our text field entry, and it's going to be a tk.entry, and it's attached to root, and text equals enter your name. And then we're just going to pack that on. So I'm going to pack it on right after my button. So I'm just going to say entry dot pack. Oh, make sure I spell entry right. Dot pack. And there we go. Now my entry is on there. And then what we want to do with that is we're going to run that first so you can just see what it looks like. So there's my entry, and I can put my name in there. And I close that. And then what we're going to do is we are going to create a submit button. We're going to read what's in there, because that's going to be an interesting thing to do. So what we'll do is we'll do that in our on button click. So what we're going to do is on our button click, we're going to read the value that you've typed into the entry. So I'm going to leave my button clicked on there, but to get the entry value, I'm going to say entry.get. That will tell me what text is in there. And I'm going to make text equal entry.get. Then I'm just going to say print, and we're going to do an F. You typed in our text. And then we'll just run that one. So you can see simply how to get the text out of this box. So if I type in there, click me, you typed DFSFFSSS. So that's basically the way that you find out what text has been typed. So again, on this button click, we could do anything with that text. So we could say, you know, if text, actually, let's just do, we're going to do it this way. So we're going to say if text print that. I'm going to go to the end there and say else print type some text. Then if we run that, we can see if nothing's typed in the box, it's going to say type some text. If I type some text, it'll say you typed hello world. So it can read that box, and it's set up by me clicking that button. And basically, you can do anything you like with that text. So if the text is something particular, you can do something with that. Now, one thing I want to show you is how to use a grid. So the layout of that little app I just did was a bit wonky. So we're going to do a grid now. So I'm literally going to switch my stuff out of here. I'm going to just save that one more time. No, it's already saved. So I'm just going to delete that. And then what I'm going to do is I'm going to use a grid example. So we're going to start a new one, and I'm going to just save this as grid example. Okay. So again, when we start these Tkinter applications, we're going to do an import of Tkinter as TK. And then we're going to create our main window again. So we're going to call it root, and we're going to say tk.tk. Don't forget our parens. And our root.title, that's just the window title basically, is going to be grid example. And the root geometry will make it the same. And we're going to add a label, or label 1. And that's going to equal a TK label. So that's the widget, is a TK label. It's going to be attached to root, and its text is going to equal first name. Then I'm going to create the grid. So I'm going to say label 1 dot grid, and he's going to be on row 0 and column 0. So that puts my label 1 in the grid. Then I'm going to say entry 1 equals a TK entry. And we're attaching that to root. Then I'm going to say entry1 dot grid. He's going to be in row 0. Oh, his row equals 0 and his column equals 1. So imagine this as a grid. We have the label on the left and the entry on the right. Then I'm going to put in a second label. Just going to call it label 2. It's going to be a TK label widget. It's attached to root. Text is going to equal last name. And put colon after that first name as well, because I think that'll look better. And then I'm going to say label 2 dot grid, and label 2 is going to be row 1 column 0. And then finally, I'm going to do an entry 2. It's going to be a TK entry that's attached to root. And entry 2's grid. Yes, you guessed it. It's going to be row equals 1, column equals 1. And then I'm just going to create an exit button. That's going to equal a TK button. It's attached to root. Its text is going to equal exit. And the command, this time I'm not going to set up a function for that. I'm just going to say it's command equals root.destroy. And I'm just going to get rid of my window straight from there. So that'll be my exit button. And then I've got to give my exit button a place. So my exit button dot grid row equals 2. And this time I'm going to use column span equals 2. And then basically to start the GUI, we're going to do the root.main loop. It keeps the GUI running and keeps it checking the buttons and everything. So we're just going to do that. Then we're going to run it, see if we typed everything correctly. Okay, so looks like I got this part here. When I put that in, it should be as, it should be T and lowercase k. I'm just going to rerun that. And there's our grid. And you can see the first names to the left. Here's the first box, the last name to the left. And there's the second box. And then our exit button is below there. So that's the way to use the grid with Tkinter. And again, I encourage you to take a look at PyQt as well, because PyQt is a different method, but it's a little bit more flexible and looks a little nicer in my opinion. But you know, from the point of view of being able to handle events, you've seen how we can do that. And we can also bind keys, so we can make it so you can check a key as well. So you can use the root.bind and then pick a key and then bind that to an action as well. So you can certainly do that with our Tkinter. So you've learned how to create a basic window, how to set the geometry, how to add some buttons, how to add some labels, how to make buttons do things. And with those basics, you can create, a basic application. So what I reckon you should do next is maybe try to create yourself a little GUI. You can use Tkinter, or you can investigate the PyQt6. That's another option. And try building a simple calculator or to-do list application, and experiment with different widgets, layouts, and event handling to get more comfortable with the GUI programming, using functions, and making this whole thing come together. Now, as far as the videos are concerned, that's where we're going to end it. In the book, there is another chapter that's going to go through a real-world example with you. It's going to create a Notepad-like application, so it's going to allow you to create your own Notepad application. And it shows you how to do that, and it uses all of the things from the book. So variables, of course, and control structures and functions, and varying things, saving files, opening files, bringing all that together, and closing the application, and data types, being able to use different data types and variables, and all of those things are in this application. And as far as being able to create an application that you can distribute, in the book, there's an addendum on turning your program into a standalone application. So it shows you how to use PyInstaller to create a standalone application. And you can create the Notepad application as a standalone application. So that's all in the book. If you want to move on from these videos, that's certainly a way to do it, is to get the book and continue your learning journey. Now, if you've enjoyed this series and you'd like me to create more, I'm interested. If people are interested in another book, I might do that. Certainly, I would be happy to do something with PyQt and do a more GUI application and show you how that works, to work with classes and to create something that you can use on any desktop. So if you've enjoyed it, give it a thumbs up. If you haven't subscribed to the channel, please do so. Adventures in Creation is not just about Python programming. We do a lot of stuff with FreeCAD and design and 3D printing and CNC routing and making things and woodworking and all kinds of things. So it's a fun channel. I enjoy doing things. I enjoy sharing it with people, and I really enjoy the interaction. I'm working with people all over the world who contact me and ask me questions or ask my input on stuff, or just to show me what they've done. And some of the things that people have achieved are fantastic. So again, Adventures in Creation, if you haven't subscribed already, please do so. And I'll look forward to making the next video.